All right, this video is the start of the calculus magic that is this section. Watch what we've got right here, okay? So example 4. Differentiate the following. Part A is going to be f of x is equal to the natural log of x times x plus 1 times x plus 2. And before you go, whoa, this looks like a nightmare. How am I going to do this? Right? The derivative of the natural log is going to be 1 divided by the inside. That's easy. 1 divided by this. Times the derivative of the inside. The derivative of this, though, we're going to have to use the product rule twice. It's going to be a nightmare. All these things getting multiplied by each other are going to give us a headache. What if we could split them up? Well, we can. Okay, so split up first. If you do not do this, you will not survive this section. If you try to do this section without splitting things up, your family is going to walk in on you like melting, soaking into the carpet. And 1, they're going to be upset because they have to clean it up. And 2, they're going to be upset because you're probably not alive when you're doing that. So don't do that. Split it up first. Save everyone a lot of heartache. Okay, I would be very sad as well. All right, so split it up. So f of x, right, this function, these are getting multiplied by each other. And we said, okay, if I have the logarithm of things multiplied, we can just add the logs together. We're going to have the logarithm of the first plus the logarithm of the second plus the logarithm of the third. And now this is immediately much easier to differentiate because we can just now do them individually. So f prime of x, the derivative of a log is 1 over the inside. Okay. So plus the derivative of this one, 1 over the inside. Times, so we don't have just x here. So we have to multiply by the derivative of the inside, which is 1. Plus the derivative of this is 1 over the inside. Times the derivative of the inside. The derivative of x plus 2 is just 1. So again, we can get rid of those ones. It's going to be 1 over x plus 1 over x plus 1 plus 1 over x plus 2. And you could combine these fractions if you wanted, but I really don't think you need to. So we're just going to leave it like so and be done. Way better than if we had to use the product rule and the quotient rule. Let's take this up a notch. All right. This is number 37 from the book. Y is equal to the natural log of the square root of x times e to the x squared plus 1. So again, this would be ridiculous if you just try to take the log right now. Let's add parentheses. It would be 1 over the inside times the derivative of the inside. We'd have to use the chain rule. We'd have to use the product rule. We'd have to use the chain rule again, and it'd be a headache. And honestly, it's still going to be a little bit of a headache. I won't lie to you, but it will be much less of a headache here. Okay. So let's split this up first. The natural log of this, remember square root, right? The square root of x is just x to the 1/2. So that square root, that exponent comes out in front. We get 1/2 the natural log of the inside, which is just x e to the x squared plus 1. Already is looking better. We don't have a square root. Okay. So next, 2 things multiplied by each other means we add them together. But be very careful right here. If we add them together, they both have that 1/2, right? 1/2 is in front of everything. So it'll be 1/2, because there's the 1/2, the natural log of the first thing, plus it still has that 1/2, the natural log of the second thing. And oh my goodness, look what's about to happen. We have the natural log of e to something. These are inverse functions of each other. The natural log of an exponential, they cancel each other out. We're just left with the exponent. So this first thing is 1/2 ln x. The second thing is 1/2 times, these cancel each other out, just x squared plus 1. Whoa, that is nice. So we can simplify a little bit more before taking the derivative. 1/2 ln x. This becomes 1/2 x squared plus 1/2. And look how much easier this is going to be to take the derivative of than what we started with. Okay. Also, for those of you who didn't see this on Wednesday, I did promise you I'd show you guys the monkey tail. So you got it in all of its glory today with 3 videos. All right. So now we can take the derivative, right? We needed to take the derivative. So y prime is going to be the derivative of this, 1/2 ln x. The 1/2 is being multiplied, so it stays the same. Derivative of natural log is 1/x. Plus the derivative of the second thing. The 2 comes down, 2 times 1/2 cancels out. Plus the derivative of the third thing, well, derivative of a constant is 0. The derivative is just 1/2x plus x, which imagine doing the derivative like this. Chain rule into chain rule again, into product rule, into one more chain rule. Okay, that's a lot of rules. Whereas this, we just use some log properties to simplify. And you might say, at this point, big whoop, hooray. Jason, this is stupid. When are we going to take the derivative of something like this? Well, I'm going to show you in the next video. If you can do derivatives of this, you can do derivatives of so many things that you never even dreamed of. Okay, so this is where the exciting part happens, but not for you, because you're going to stop this video. You're going to do the relative corresponding homework problems, and then you're going to wait and do the next video. All right.